Hello, everybody, and welcome to our free webinar on uncertainty of measurements in the ISO 17025, the new version 2017. You are most welcome to our website, to visit our website. You are most welcome in our webinar today. My name is Dr. Mohammed Saad. I am the technical experts of accreditation in Speed Global, and we will have our webinar today will be presented by Engineer Khalid Sadiq. He's the accreditation expert in Emirates International Accreditation Center, IEC. Let's have a quick introduction, and we will go directly to the our webinar today. This webinar is presented by Speed Global. It's an American company, provide the conformity assessment services, especially the proficiency testing, inspection, personnel certification, and management certification and training. These are the activities. And regarding the proficiency testing, Speed Global provide construction material proficiency testing samples, metallurgical, non-destructive testing, and other customized programs in different areas, which can be tailored according to the needs of the labs. You can know more about the programs in the website, and also we will send you the brochure for all the services. Also, we want to inform you regarding the personnel certification. There is a new certificate for ISO 17025 lead auditor, and this certificate is recognized and accredited from the American Accreditation Association. So the one who will pass the exam will be recognized in the American Directory for Competent Persons from the American International Accreditation Association. This is just quick introduction. We will send you in the group, in the WhatsApp group, we will send you the details of the proficiency testing and the personnel certification, and you can visit the website to know more about that. We are welcoming Engineer Khalid Sadiq today. He will be our tutor for this introduction. Just I want to confirm this is just awareness session and about the requirements of the uncertainty in the new standard. It's giving the basics of the uncertainty, and we promise you that very soon we will launch a specialized training course for 3 days only for estimation of uncertainty. So today, of course, we cannot go for the estimation of uncertainty, which is a lot of statistics, you know, but we will do that very soon, and we will send you all the links to that session. But today we are going to have the free webinar, and now Engineer Khalid Sadiq can start his presentation. So please.
Okay, good afternoon. I'm so glad to be with you today and our webinar, free webinar for how to estimate uncertainty. And for Speed Global staff, I'd like to thank you so much for your great efforts to arrange this type of webinars to introduce our service to all employees which interested in the field of accreditation, in the field of ISO 17025 standard. As you know, estimation of uncertainty, one of the major requirement of ISO 17025 standard in the updated version 2017, and also in the old version 2005. All laboratories which need to be accredited, it should to be implemented the estimation of uncertainty of their results of their test results for all types of quantitative tests. To start our webinar or to our presentation, we need to answer for four type of question: what, who, why, and how. What's the meaning of accreditation? This is the first question. And who need to estimate uncertainty? Why our laboratories requested to implement it or to estimate it uncertainty value, and how to estimate the uncertainty. This is the four questions which we will study today or try to answer during our presentation, which may take from 30 to 45 minutes. And by the way, if you have any question, you can directly go to our website or our group to introduce your questions. Inshallah, we will try to give you our or provide you our answer for all your questions. So, before starting for what is the meaning of uncertainty and before introducing official definition for uncertainty, we need to discuss physically what's the meaning of uncertainty. As you know, in many aspects of everyday life, we are accustomed to doubt about arrays when estimating how large or small things are. As example, if somebody asks, what do you think about the temperature of the room is? We might say it is about 23 degrees Celsius. Without measuring, by sense, you can say it is about 23 degrees Celsius. So the use of word of about implies that we know the room is not exactly 23 degrees, but is somewhere near from it. In other words, we can recognize that there is some doubt about the value of the temperature that we have estimated. So we could, of course, be a bit more specific to say is, as we written now, is 23 plus or minus 2, plus 23 plus or minus 2. So we could say it is 23 degrees Celsius, give or take a couple of degrees. Now we are assigning limits. When we say 23 plus or minus 2, so we are assigning limit to extent of doubt. We have give some quantitative information about that doubt or uncertainty of our estimation. Okay, so for example, or another example also, we may be more sure if we say that the temperature is 23 plus or minus 5. First example is 23 plus or minus 2. Here we mention 23 plus or minus 5. We may be more sure that our estimated within, if we say 5 degrees of the true room temperature, then we are that it's within 2 degrees. So uncertainty is related to the level, or now we assigning limits to the extent of doubt. We have given some quantitative information, as I told you. So in this case, when we say 23 plus or minus 5, uncertainty here is related to level of confidence. The larger the uncertainty we assign, the more confident we are that the true value. If we say 23 plus or minus 5, there is more confidential of our estimation, more than if we say 23 plus or minus 2. So before starting also to introduce the official definition of uncertainty, we need to ask some question. When we measure the temperature of our room, is the thermometer is accurate? We need to ask this question. Is our thermometer, which we are using to measure the temperature in the room, is accurate or not? How can we read it? How can we read the temperature? Is the reading change or still constant? And also, does it matter where in the room I take the measurement? In the middle of the room, of the corner of the room? I am holding the thermometer in my hand. Am I warming it up or not? So there's some, the answer of this question give me more and more uncertainty of our reading. I don't know, or I am not sure the accuracy of my thermometer. I need to explain or introduce how can I read the temperature degree. Is this reading, is it change or constant? All these parameters can also introduce to increase my doubt about the reading of temperature. So all these factors, and maybe more and more factors, may contribute to the uncertainty of our measurement of room temperature. We can go directly now to the definition of uncertainty. Uncertainty, an estimate of a range of value about the measurement value in which accepted value is believed to lie. Or there is other also official definition. Uncertainty is a parameter associated with the result of measurement that characterize the dispersion of the values that could reasonably to attribute to the measurement. This is the official meaning or official definition of uncertainty, as you see. Also, we need to, okay, a minute. Okay, we need to introduce very important point that there is very different, or the big difference between uncertainty and error. Sometimes there is somebody was confused, or uncertainty is equal to error. No, there is a great difference between both of them, because error is a result of measurement minus a true value of measurement. If you have actual value is 25 as example, and your measurement is 24, so the difference between actual value and your value, we can say that is the error. So we can ask, what is the sources of uncertainty? What's the sources of uncertainty? The sources of uncertainty, like an instrument effect or stability or linearity, environmental effect, sampling process, human errors, reference material, homogenization effect, and test method, and contamination during sample preparation, and the storage condition. All these types of source can be contribute to introduce the value of uncertainty results. Okay, this is the first, our answer for the first question is what is the meaning of uncertainty? So we can go to the second question is who need to calculate the uncertainty value? Customers, of course. Customer need together with the results make correct to have a correct decision. Sometimes your customer asking to introduce or to provide the uncertainty value to help them to take or to make the correct decision in their results. Also, the laboratory itself, the laboratory need to know its own quality of measurement and to improve in the required quality. So, third question is why we need to estimate uncertainty. As I told you before, sometimes your customer asked you to mention the uncertainty value, and the more important point is to comply with ISO 17025 requirement. As you know, in our standard 17025, there is a complete clause, is clause number 7.6. 7.6 in our standards related to estimation of uncertainty. So your lab should to comply with this requirement. To comply for this requirement, you should to estimate your uncertainties. This is why you are requested to implement or to estimate the uncertainty. As you see here in the presentation, there is the definition, the requirement for 7.6, 7.6.1. You see, laboratory shall identify the contribution to measurement uncertainty, and when evaluating measurement uncertainty, all contributions that are significant, including those arising from sampling, shall be taken into account using appropriate method of analysis. Also, 7.6.2, a laboratory performing calibration, including of its own equipment, shall evaluate the measurement of uncertainty for all calibration. So, my dear, for calibration laboratories, it is mandatory to estimate uncertainty, and also it is mandatory to mention the results of uncertainty in their calibration certificate. And this is the difference between calibration lab and testing lab. 7.6 is related to both laboratories, for testing lab and the calibration lab, but for both of them, calibration laboratories and testing laboratories, are requested to estimate the uncertainty of their values, but for calibration certificate also it is mandatory to mention the estimation of uncertainty in the final certificate. Okay. Also, as you see, laboratory performing testing shall evaluate measurement uncertainty. 7.6.2 related to calibration and 7.6.3 is related to testing. The laboratory performing testing shall evaluate measurement uncertainty, where the test method, procedures, evaluation of measurement uncertainty, and estimation shall be made based on understanding of theoretical points. This is why we should to estimate uncertainty to comply with all these points. Also, in the same clause point 7.6, the lab shall identify all components of uncertainty and make reasonable estimation, establish reporting of not giving wrong impression of uncertainty, and also the lab should to have reasonable estimation. It should to be based on knowledge of performance of test method and the measurement scope and the previous experience of and validation data. All this statement, my dears, is related to a requirement of 17025. Okay, so if we start to discuss about how to estimate the uncertainty, it is very important question. Now we can say that we know what is the meaning of uncertainty, and we can know also why we can or why our lab are requested to estimate uncertainty. But the more important question is how to estimate uncertainty. For estimating uncertainty, we have two types, type A and type B. We should to calculate type A, and also we should to calculate or estimate type B, and after that we can combine together type A and type B, as I will introduce after a minute. Okay, how to calculate the uncertainty regarding to type A? First item, my dear, or first step is to get the mean value of results. As example, if you perform any pH test as example, and you will take five reading, individual reading, Q1, Q2, Q3, Q4, Q5 as example. You are requested to get the mean or the average. Of course, it's very simple to get mean or average of these results. Next step, to get standard deviation. Standard deviation, as you see in this equation, second equation, is related to, there's some parameter as you see. N here, N is related to or reflected the number of reading, number of individual reading. If you have 10 reading, it means you should to mention N equal to 10 or 5 or 8, according to your individual results. QI is related to individual results, Q1, Q2, Q3, Q4, and Q dash or Q bar is related to the mean value, which you have get from the first equation. So first we get mean, Q dash or Q bar, and after that you can get standard deviation by mention mean and individual results, as you see in equation number 2. After that you can get directly to get type A. Type A value is by using the also standard deviation as mentioned in equation number 2, dividing by the root of N. N is the same number of reading. So you get standard deviation from equation number 2 and dividing it for root N. N is reflected the number of reading, as you see. Here it's very simple to get type A. As you see, type A is directly from your results. Also, I need to mention very important point that mention type A is including random component. Random component, it is required. How to get type A, and type B is different. So type A is basically using your individual results of your test. There is no any sharing or other contribution of any other sources. No sources contribute to get type A except your individual result, as you see, starting from mean, standard deviation, and get repeatability or type A reading. Okay, now we can go to how to estimate type B. Type B. Type B normally is constant in your lab. It is constant, and there is some sources you should to mention to get type B. Okay, as you see here, to evaluate type or to estimate type B, you should to using some contribution or some sources will be contribute to get type B. First one is related to calibration uncertainty value for calibration certificate. So as our examples, if you are conducting or performing pH test, you can go directly to pH meter to get the calibration certificate of pH meter, and to identify or to get the uncertainty which you already mentioned in the calibration certificate. And this point is the answer of very important question. Somebody is asked about the calibration body. You should to any accredited lab, testing lab, should to perform the calibration process in accredited laboratories. Why? Because the accredited calibration lab, one of the requirements of accredited calibration lab is to mention the uncertainty in the final certificate. So it will help the testing lab to, when receiving the calibration certificate, to get the calibration value, uncertainty value directly from calibration certificate. So the first value for type A is the uncertainty value, which you mentioned already in your calibration certificate. Your lab or yourself, you will not do any effort for this point. You go directly to uncertainty certificate to get or catch the uncertainty which you mentioned in calibration certificate. So second point or second parameter for type B is related to the equipment, the resolution of equipment. What's the meaning of resolution? You can get the smallest value you can read through your equipment. As example, if you have rule is dividing into 1 meter, 1 millimeter, 1 millimeter, 2, 3, 4. So the resolution in this case is 1 millimeter. And if you have Werner caliber, as example, Werner caliber, and its accuracy is, or resolution is 0.01 millimeter. So the resolution which you will use in this case is 0.01 millimeter. If you have balance, the balance is resolution is 0.0001 gram. So the resolution in this case is 0.001 gram. So you will get directly to get the smallest value which you can find in your equipment or your instrument. Also, as you see, you will not do any efforts for type B. You can directly to use the accuracy or the resolution of your equipment to mention the second parameter. It's related to the resolution of equipment. Third point or third source is related to the draft. What's the meaning of the draft? You can get to you can take your calibration certificate for last year and calibration certificate for this year, 2019 and 2020, as example, the calibration certificate. You will have the uncertainty or take the difference between last year, the uncertainty of last year, and uncertainty of this year. The last year minus 2019 minus 2020, the uncertainty value which mentioned in calibration certificate. You can using this value as a drift. So this is the third source of uncertainty for type B estimation. Fourth one and last one is related to the effect of environmental condition of your lab, because environmental condition can affect the reading of uncertainty. Okay. As you see here, this is the meaning of resolution. The resolution. You can see first figure at the left, 23, 22, 23, 24. Dividing to 1 millimeter, 22, 23, 24. While the next one is 23, 23.5, 24. It's meaning that the dividing into 0.5 millimeter, while the last one is 23 by 0.5, 52. It's meaning that the here resolution is 0.01. So the resolution in the first figure is 1, second figure is 0.5, and third one is 0.01, as you see. Okay, so now we get type A and we get type B. So how to combine, how to make the combination, and how to get final results of uncertainty. You can use, as you see, this very simple matrix or table to calculate or to estimate uncertainty, as I'll explain now. First source here, we have source of uncertainty, value, distribution, divisor, and contribution. First one is U. U is meaning uncertainty, my dear. Uncertainty related to type A. Did you remember here? Here, you get mean, standard deviation, type A. So the results which you will take from type A, you can directly go to mention in value of type A. Okay, so after that, we can make, we're using some statistical, of course, we can't discuss for this point now because of the limitation of time, but it is normal distribution. In this case, you can divide this value by divisor number equal to 1. When the distribution is statistically, when distribution is normal distribution, we can divide the value by 1. So if the type A value is 10, we can divide this value for divisor 1. So the contribution here will be 10. 10 by 1 will be 10. Okay, number 2 is the uncertainty related to type B. And we have several sources, as you know, as here. As we discussed here, for type B. So, number 2, uncertainty related to calibration certificate. You will go directly to calibration certificate of your equipment and mention here the value directly. Value may be, as example, 1. Okay, so we can divide this value by 2. We'll divide it. This is a constant, my dear. Divisor here is constant number. For type A, we can divide it by 1. For calibration, we can divide it by 2. If your calibration certificate mentions the uncertainty is 2, so 2 by 2, it will contribution will be 1 in this case. After that, we can go to the third one is related to, also for type B, related to resolution. Resolution. So we can directly go to the smallest value which we can read from your equipment, and you can divide this value by 2, and after that divide it for rectangular by 1.73. Again, to get the resolution of your equipment, you get as example for ruler is the minimum value is, or the smallest value you can read is 1 millimeter. So you will take 0.5 of this value, so 0.5 millimeter, and after that you can divide by 1.73. Another example, if resolution is 2, so you can take half of 2 is 1 and divided 1 by 1.73 to get the contribution of resolution. After that, you can go directly for drift. What's the meaning of drift? As I asked, also sorry, for resolution related to type B, as you see, there is no efforts performed by yourself. Directly get to the equipment and mention this value. For calibration is constant, and the resolution also is constant value. For drift, you can get 2 calibration certificate, one for 2019 and the other for 2020, and get the maximum uncertainty minus the minimum uncertainty, and divided this value by 1.73. Finally, for environmental in a large large number of laboratories didn't have a direct effect of our measurement. But here you can see again to review for type A, It is not constant, my dear. It is not constant. It is depending on your individual results. If you have 5 reading, if you have 10 reading, if you have 20 reading, if you have 3 reading, whatever, for each test, you are requested to get the value and get mean, standard deviation, type A, or repeatability, and mention the results here in value. And dividing this value by 1 to get the contribution here in the last column. For type B, you can go directly for calibration certificate to get the uncertainty of your equipment, and directly divided by 2 and dimension in contribution, the last column. For resolution, you get the smallest value you can read in your equipment, dividing by 2 and dividing after that by 1.73. For drift, you can get the difference between the uncertainty of 2 calibration certificate and divided by 1.3. As you see, my dear, you have a lot of results, but how to get the combination, how to collect all these results to get the final results of uncertainty. As you see, we have 2 other in the bottom, combined uncertainty and expanded uncertainty. Combined uncertainty and expanded uncertainty. Okay, how to get the combined of uncertainty? Combined of uncertainty is very easy to get. As you see, you get your repeatability, your calibration, your resolution, your drift from the previous table. As you see, you get the square number of U repeatability plus square of U calibration plus screw of resolution, and also for drift, and get the root of all this value. It is very simple to get the U combined or combined of uncertainty. Last point or last step to get uncertainty is expanded uncertainty. Expanded uncertainty. How to get expanded uncertainty? It is very easy. Is by using the bottom equation. Is U expanded is plus or minus K multiply for U combined. You get first one is combined uncertainty. You can multiply by K. But take care, what is the meaning of K? Okay. Normal case, in normal case, as you see, you get U expanded, it's equal to K multiply for your combined. You combined already, you have estimated. And K is equal to 2. It's the selecting of K equal to 2 is according to the requirement of ISO 17025, is asked to using K equal to as a constant number, K equal to 2. So directly you can get U combined, multiply by 2 to get the U expanded of uncertainty. But we have very special case. Very special case. It is normal, not normal case or abnormal case. It is using KB instead of K. Sometimes we get U expanded, we multiply U combined by KB, not by K. When we are using KB instead of K, in the case if U combined, the half of U combined, as you see, 0.5 U combined is less than the type A of uncertainty. We can go again to our table. As you see here, first item is the uncertainty related to type A. In normal case, K equal to 2, as I discussed before. In this case, U related to type A should to be less than 0.5 U combined. As example, if U combined is 4, so UA should to be less than 2. If U combined is 3, UA, first one, is should to be less than 1.5. In this case, you can use normal, it is normal case to use K equal to 2. Okay, but in special case, if UA is greater than 0.5 UC, here, UA is greater than 0.5 of UC, you should use KB instead of K. here. Okay, KB is confidence probability. Confidence probability. How to get KB? We can get KB directly by using the attached table. It's constant number, and it is mentioned in several sources of uncertainty, and we can ask InSpeed Global to provide you for our guide, international guideline to estimate uncertainty, which including these types of table. We can get KB from this table by using V effective. As you see, V effective. Also, how to get V effective? I need to get V effective, and using these tables to get directly KB. So how to get V effective? You can see in this very simple equation, very effective is equal to n-1, and as you see, UC and UA. UC is U combined, and UA is repeatability or type A, uncertainty of type A. Of course, you have UC from the table, okay? And also you have UA also from the table. And N is a number of reading, as you know, number of reading, 5, 6, 10. So directly you can get V effective. By using V effective, we can directly go to the table to get the corresponding KB. In this case, after get KB, we can directly go to get U expand. Second equation, U expand is equal to UC multiplied by KB. So we have two types. So again, we have two types of U expand. U expand is equal to K multiply U combined, or KB multiply U combined. In normal case, we will use U expanded is equal to K multiply UC, where K is equal to 2. In the another case, if, as I told you, type A value is greater than 0.5 U combined, we go directly to equation number 2. U expand is equal to KB multiply UC. So now we get the final results of uncertainty or expanded uncertainty. So the other point is how to report the result of uncertainty. How to report. If due to this equation, we get expanded uncertainty is equal to 0.5 as example, 0.5. So we can go directly here. Or 0.1 would be the same example here. 0.1. Your result is 23. Don't forget that your main results of average. If you get 5 reading of VH, you get the final result is by the mean or average is 23 as example, and it makes this calculation to get the uncertainty, which is equal to 0.1. How to report this value? As you see, in this case, we can report is 23 plus or minus 0.1. It's meaning that this value is meaning that the final result is 23, but the expanded uncertainty has been calculated for a coverage probability of 95%, K equal to 2, or KB equal to any other results. The value is measured as 0.1. I can understand from this report that your final result is 23 and your uncertainty is 0.1. Also, I can understand that 23 is not the actual results. It's not the actual results. But I can say that actual result is lies between 23 plus or minus 0.1. Or in another word, between 22.9 up to 23.1. Actual results, I didn't know. Nobody of the world can say that he know the accurate results. But we can say that actual results is in between 22.9 and 23.1. Of course, I have finished now, but of course I can expect that there is some problem in uncertainty, to be honest. It's not simple as I introduced. There's some problem. Sometimes there's, we are using 2 or 3 equipment, not one equipment in our test. We can use Ference, and you can use Werner caliber. You can use balance in the same to perform the same test. So in this case, we can. It is a problem. No, it is not problem. We can go directly again to the table. Yeah, this table, and instead of UB calibration, we can mention all calibration certificate. If you have two type of equipment, you have Ference and balance, you can say that U calibration for balance, and next cell is U calibration for Ference. And the same for resolution. We can divide this cell into two cells instead of one cell. One cell for balance and the other for oven or anything in any other equipment. The same for drift, and you can use the same equation here for U combined, but of course U repeatability is the same. In U calibration, instead of one term, you will get two terms. U calibration for balance plus U calibration for Ference. U resolution for balance plus U resolution for Ference. U drift is the same as resolution and calibration. This is the first point, or the first question, or first threats which we can face for performing uncertainty. Second one is related to qualitative test, because as you know, for quantitative, no problem. Quantitative, we can get any test and get results, get mean, standard deviation. Type A, it will be very easy. But what can we do for qualitative results, which we're not including any quantitative results? In this case, we go directly for type B. There is no type A in this case, but of course, this type B. We have equipment, that means we have calibration certificate. We can get the resolution, you can get the drift, and it will be constant number, as you see. For reporting, also reporting the uncertainty value. For calibration lab is mandatory to mention the uncertainty value in the final report. Again, for calibration lab, it is mandatory to mention the uncertainty. It's not optional, It is mandatory to mention it. For test lab, you can mention your results or not, but in some cases, it is also mandatory for testing lab to mention the uncertainty value in some special cases, such as upon customer request. If your customer asks it to mention uncertainty value, you should do. Second point, if it is requested by your technical standard. If your technical standard which you are using to perform the test, one of its requirement is to mention uncertainty value in your report, you should do also. Third and last point, and this is very important, is if the uncertainty value can affect the conformity of a specific limit to accept or to refuse the product. If you are, as example, first party lab, and you are performing some test in some milk, as example, or some iron, or some steel tensile test, any type of test, and you get your results and get also your uncertainty, and you know that uncertainty value may affect the conformity statement to accept or to refuse the product. In this case, you should to mention the uncertainty value in your final report. Thank you so much. And I know, of course, that is this very simple presentation, and I am sure that we need more and more time to explain the statistical analysis and how to get a type A deeply, and how to get sources of type B, and how to get the estimation of uncertainty, and give some more and more examples. I know that somebody need to know how to get practically how to estimate uncertainty in their own activities. But inshallah, as Dr. Muhammad promised, InSpeed will arrange, I think, in the future very soon, some activities related to this point. Thank you so much, and thanks, and Dr. Muhammad, please.
Thank you, Engineer Khalid, and thank you, everyone. I just want to confirm several points. This is, as we agreed, this is a starting point for understanding the uncertainty. And we are going to have a very detailed training course for 3 days, which help you and take your hand to calculate exactly your uncertainty results. during this course, the next course, we will guide you and give you the Excel sheet you will use to the calculations, the guide which you will use to understanding exactly how to estimate your uncertainty, especially in your lab. This is just today as introduction, and the detailed information will be given in the next training course. It will be the next month, and we will send you all the details about that. I just also want to confirm that we have many questions from your side. All questions are most welcome, but we try to concentrate on the information in this session, and in the WhatsApp group we will answer your questions there. So please, for any questions, please provide that in the WhatsApp group, and we will do our best. We are more than 210 participants now, so we will do our best to answer your questions, and we will do our best to guide you to the professional work of the testing through understanding the uncertainty, through providing you with the samples for proficiency testing. As I told you, we provide proficiency testing samples which is accredited according to 1743 from the American accreditation body. So please, for any questions, you can start writing that in the WhatsApp group. We'll do our best for that. Thank you for having your time today, and we will send you, I hope if you are still in this group, you will get the exact time for the training course, which will be soon, and we will do our best to give you in that course. It will be 3 days, giving you full day, giving you all the details which you can imagine for calculating the uncertainty, understanding, guiding you through that. Also, you will get soon the training and the certifications system for 17025 lead auditor, which I'm sure it will help you to be qualified as certified lead auditor for 17025. Thank you very much for your participation today. This session was recorded, and it will be published in the YouTube channel. You will get the link through the WhatsApp group so you can go back to get any information you missed from that. Thank you, Engineer Khaled, for your time, for your valuable information. Thank you, everyone. Thank you for joining us today, and we promise to provide you more and more of the training courses and valuable information, and hoping to see you all in a safe and in a good health. And we can say now goodbye and see you very soon.